When the two remaining local car manufacturers closed their doors in October 2017, every vehicle sold in Australia will be imported. These imported vehicles are designed and built on global platforms and in many cases must be modified to make sure that they are safe for the intended use. Australian automotive suppliers have become global leaders in the design and manufacture of high-quality four-wheel drive and SUV parts and accessories, improving the safety and functionality of vehicles. To confirm the safety of the products that these suppliers design and manufacture, the Australian automotive aftermarket industry has undertaken extensive independent testing, both in Australia and in the USA, to validate the engineering integrity and ongoing regulatory compliance of vehicles. In 2015, the Australian automotive aftermarket industry undertook suspension tests on 5 separate vehicle platforms in the USA at a cost of $250,000. This was done to dispel the notion that small changes to the ride height of a vehicle have a negative impact on electronic stability control operation. In these tests, the industry adopted the same test protocols used by all vehicle manufacturers and major component suppliers around the world. Technical reports from the tests presented to federal, state and territory regulators showed that the test vehicles all met Australian design rule requirements for electronic stability control operation. Despite this evidence, Minister Paul Fletcher and his department are about to make it much harder and more expensive to modify vehicles. A leading independent engineering firm supervised a handling comparison test of a current model Mitsubishi Triton with its original suspension and braking system and an identical vehicle fitted with an upgraded suspension kit supplied by a leading Australian aftermarket manufacturer. Key handling data, including cabin roll, steering angle and velocity, was monitored on the two vehicles as they were each put through a series of dynamic tests on bitumen and gravel surfaces, firstly carrying no additional weight and then loaded up to the full carrying capacity of the vehicle. How did they perform? The test results demonstrated that steering angle inputs and body roll were significantly lower for the aftermarket modified vehicle across both the standard and fully loaded configurations, despite the fact that the modified vehicle was carrying an additional 200 kilograms in weight in the fully loaded configuration. Less steering angle input directly relates to reaction time and the feeling of connection between the driver and the vehicle, and is a critical reference in terms of the vehicle drivability and overall safety, including driver fatigue. In fact, the fully loaded modified vehicle required over 40% less steering angle change than the unloaded original spec vehicle. During all tests, the ESC system performed exactly as it should. The driver reported that the modified vehicle was far more responsive to steering inputs and would settle into each phase of the manoeuvre more quickly and felt more stable, which allowed the vehicle to be more precisely steered through the course. The standard vehicle, by contrast, required more aggressive steering inputs to compensate for the lag between when the steering input was applied and when the vehicle would respond. The vehicle in general felt less easily controlled, and the ESC system engaged noticeably on many of the runs. The test results concluded that the aftermarket modified vehicle either met or in most cases exceeded the ride and handling benchmarks set by the original spec vehicle, including the continued functionality of all critical safety systems such as electronic stability control. Which vehicle would you want your family or your employees to be driving?